So in today's lecture, we are going to start electrostatics, right? Statics. And the first thing we will going to discuss is the Coulomb's law, right? Coulomb's law. What is the Coulomb's law, you tell? If there are two charges Q1 and Q2 are separated by distance, so the electrostatic repulsive or attractive force may be over there, right? So if the charge are same or they are like, the force is repulsive. If they are opposite sign, then the force is attractive. And the force is proportional to the product of the charges and inversely proportional to the square of distance between them. Therefore, the electrostatic force Q1 Q2 may be written as K Q1 Q2 upon R square, where what is K? K is the constant 1 upon 4 pi epsilon naught. Its value is 9 into 10 to the power 9. So the electrostatic force 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Is it clear or not? Where what is epsilon naught? Epsilon naught is 1 upon 36 pi, right, into 10 to the power 9. Its value comes to be 8.85 into 10 to the power minus 12. Right. What is the K? K is the constant. This is the epsilon naught is also called the constant. This is called permittivity. Permittivity of free space. Is it clear or not? Yes. What is the unit of K? Can you tell? Unit of K. It is Newton meter square into Coulomb square. Newton meter square upon Coulomb square. Right. The unit of epsilon naught is reciprocal of unit of K. So therefore, when you will calculate its value, permittivity of free space, the value comes to be 8.85 into 10 to the power minus 12. You have to remember, and the unit will be just reciprocal the unit of K. Is it clear or not? Yes. Copy this fast. So for example, we can do some questions. Suppose this is the 2 microcoulomb, this is plus 2 microcoulomb, and this is 4 microcoulomb, and they are placed on the side of the equilateral triangle 3 meter 3 meter, right? You have to find force on, right? Force on 4 microcoulomb. You have to find the force on this charge. This is the plus 2 microcoulomb, this is plus 2 microcoulomb, right? So how to find the force? All the charges are of similar, right? It is plus, it is also plus. So the force on this charge will be in this direction. Because of this, the force will be in this direction. It is the equilateral triangle, the angle will be 60 degree. Although the F1 and F2, right, these vectors are different, F1 vector and F2 vector, but their magnitude will be same, is equal to K Q1 Q2 upon R square. What is the value of K? 9 into 10 to the power 9. If I assume this is to be Q1, Q2, right, divided by the distance between them. In the same way, this is Q1 and this is also Q2. So that is why I have written the magnitude of the force F1 and F2 are same. So you can find this is 3 square, it's come to be 8 into 10 to the power minus 3 Newton. So this is the force. Now we have to find the resultant force on this. The F1 and F2, right, both are same force, and what is the angle between them? 60 degree. So the resultant force can be found with the help of formula F1 square plus F2 square plus 2F1 F2 cos 60. The value of cos 60 is what? 1 by 2. So it will cancel out. So this is F square plus F square plus F square. So this is equal to F root 3, and the value of F comes to be 8 into 10 to the power minus 3 Newton. So the answer is 8 root 3 into 10 to the power minus 3 Newton. Right? This is the resultant force. Copy this. Very good. Wait for 1 minute. Okay, so the next topic is equilibrium of 3-point charges, right? Charges. Equilibrium of charges, right? For example, if you consider the Q and the Q1 and this is Q2, they are separated by distance r. Is it clear or not? So if this is Q1, Q2, where should be the particle, the third particle Q? Between them should be placed so that all system is in equilibrium. Find the value of small q. This is the question. And where it should be placed? It should be placed so that all system is in equilibrium. This is the question. Do you understand? Copy this. Yes. So suppose the distance of small q is from q1 is x. So this distance is what? Say r minus x. So if you consider the equilibrium of this q, so because of this charge, the force will be acting in this direction. Are you getting or not? Right. And the force on this charge will be acting in this direction. Right. So for equilibrium, the force F1 and F2, its magnitude must be same, although they are vectors. Right. They should be equal and opposite. So what is F1? K Q1 Q upon x square, K, right, Q2 Q upon r minus x whole square. When you will simplify, listen one thing, KQ will cancel out, Q1 upon x square, right, Q2 upon r minus x whole square. Take the square root, you can find the value of x q1 minus r root q1, fine, is equal to x q2. So r root q1 this side, it goes this side, root q1 plus root q2. So what is the value of x? You tell. The value of x is root q1 upon q1 plus root q2 into r. This is the value, right, from this is the distance of q from q1. Is it clear or not, you tell? Yes. And if they ask from q2, so the x dash will be root q2 upon root q1 plus root q2 into r. This is the distance from q2. This is the one part of the question. But the thing is that we not only have to consider the equilibrium of the charged particle small q, rather we have to consider the equilibrium of all the system, right, all system. What does it mean? It means along with this small q, this capital Q1 and capital Q2 must also be in equilibrium. So if you consider this is the charge Q1 and this is the charge Q and this is the Q2. This is the distance we have found with the help of the equilibrium of small q, right? Now if you consider this the Q1 and Q2, it is given in the question that both are of same sign, fine. So if you consider this the plus Q2 and Q1, the force will be exerting because of this the F1 vector in this direction. Is it clear or not? Yes. For equilibrium of Q1, this charge must be negative so that the force F2 vector acting in this direction, only it is possible when it is negative, otherwise both forces will be in the same direction. Yes. And it is not in equilibrium. So this charge Q must be what? Of the negative sign, right? So although it will come on its own, for equilibrium of Q1, the net force F1 plus F2 must be 0, right? What is the F1? The force due to Q2, K Q1 Q2 upon R square. Is it clear or not, you tell? Yes. The F2, K Q1 Q upon, the separation between them is x square is equal to 0. Fine. Yes. So K Q1 Q upon x square, it goes this side, minus Q1 Q2 upon R square. K Q1 will cancel out, minus x square upon R square into Q2. Is it clear or not, you tell? Yes. So charge is negative sign, it is coming on its own, and value of x I can put from here, minus x. This is Q1 upon Q1 plus Q2 into R whole square into Q2 divided by R square. So the Q you will get minus, this is Q1 R square Q2 upon into R square. It will cancel out. So minus Q1 Q2 upon root Q1 plus Q2 ka whole square. So the charge value must be minus Q1 Q2 upon. Fine. Copy this. So there is another illustration, right? Suppose we have a triangle and on each corner of the triangle the charge is placed at Q, and the distance between the side of the equilateral triangle is D. This is the value of Q. What should be the value of Q? Right, find capital Q. Find capital Q at centroid, at center of triangle, right? Triangle, so that system is in equilibrium. You understand or not? Yes. Listen one thing. If you consider this is the plus Q plus Q plus Q, so it should be the attractive force, right? Yes. It should be the attractive force. So these three forces, right? F, F and F, whatever the value of capital Q is, it remains at rest or in equilibrium. Why? Because the force either will be attractive or it may be the repulsive. Are you getting? So net force is 0, because if three forces F, F and F act such a way, the angle between them is 120. So the resultant force will be 0. You understand or not? Yes. Right. And what is the angle? You understand this angle is 120, and this angle is also 120, because this is 30, right? This is 90, and therefore this is 60, and this is also 60. So each angle is 120. This capital Q is always in equilibrium, but we have to consider the equilibrium of this charge. Q, Q. The repulsive force is, say, F. Are you getting? Yes. Repulsive force is what? Say F. So the resultant force plus Q and plus Q, you can assume to be plus, is in this direction. So to compensate this force or to neutralize this force, this charge must be negative and it should be F dash in this direction. So therefore, for equilibrium of Q, right, Fr and F dash, you may write in this way also, both should be equal and opposite sign. So it means this charge Q must be negative. Is it clear or not? Yes. What is the force between Q and Q? It is F. Say K Q Q upon D square. KQ square upon D square. Fine. Yes. F. What is the resultant force? this resultant force is root over F square into cos 60. Cos 60 is 1 by 2. We'll cancel this 1, 2. So the answer will be 3 F square root. F root 3. So what is the F? KQ square upon D square into root 3. Fine. So this is the resultant force. Fine. Listen one thing. If you assume this is the plus Q, right? And this distance is supposed to be x. So what will be the value of F dash? F dash value will be equal to K capital Q into small q upon x square. So now we have to find the value of this x dash. The x dash is same. Are you getting or not? Yes. So if this is d, so half of the distance is d by 2 and this is 30 degree. So how can you find the x? Apply cos 30. I am writing it this side. Cos 30 is equal to what? Base upon hypotenuse. Root 3 by 2 d upon 2x. So x is equal to what? D by root 3. So this distance is d upon root 3. This is q, this is small q, or although it will be minus q. So the force F dash we have to find. Alright. So k q upon x square may be written as kq upon x. The value of x is d upon root 3 whole square kq into 3 upon d square. Is it clear or not? Yes. Now for equilibrium, what is the condition? This resultant force must be equal and opposite to F dash. kq square d square root 3. Fine. Yes. So everything will cancel. Root 3 is equal to q3. Q is equal to small q upon root 3. Although it is the magnitude, right? But charge capital Q must be equal to minus q root by 3. All you can write this, you can add this negative sign from yourself, or one way is to get the negative sign in calculation, make fr plus f dash is equal to 0 as we did in the previous question. But you can do in this way also. First find the magnitude, put the sign from your side, right? So this is the value of capital Q, so that the whole system remains in equilibrium. So for example, in the next question, suppose this is the square. All right, this is q, this is q, this is q, this is q. So you have to find again the value of capital Q, so that system remains in equilibrium. Right. So what you have to do, again you will find for the force, suppose this is the d, this is the d, right? This is the force, suppose this is the F1 force, right? Or you may assume this, the force is what? Say F1. Because of this, the magnitude will also be F1, right? I am writing the magnitude, and because of this, this distance will be d root 2, this is d root 2, and the force will be equal to F2. Is it clear or not? So what is the F1 value? K QQ upon d square, KQ square upon d square. What is this F2 values? Tell. K QQ upon d root 2 whole square is equal to KQ square upon 2d square. Fine. Tell me, if you want to find the net force F1 and F2, what is the resultant? Ishika, please tell. What is the result? F1 root 2 and F2 is also there. So the net force will be equal to F1 root 2 plus F2. Is it clear or not? Yes. Now, if I assume this capital Q, it should be negative. first of all, and the force will be F dash. Are you getting or not? So if you assume this is distance to be x, so what is the value of x? Half of the diagonal. Very good. D upon root 2 is the half of the diagonal. So what is the value of F dash now? KQQ upon x square, and what is the value of x? Yes, this is 2 upon d square. Is it clear or not? So for equilibrium of Q, the resultant force, what is the resultant force? F2. Yes, you may write the Fr vector plus F dash vector must be 0, right? So Fr F1 root 2 plus F2, what is the F dash? This is the F dash, must be 0. F1 root 2 plus F2 vector. It means this force must be just opposite to the resultant force. F dash value 2kq d square minus the F1 square upon d square, and this is F2, है ना? 2d square. If you simplify, what will you get? K upon d square minus q root 2, and this is q upon 2. Fine. So what is the value of q? Is it clear or not? So it may be written as q upon root 2, 1 plus 1 upon 2, value will be 3q upon 2 root 2 is the correct answer. Wait for 1 minute, this is root 2. I have made a mistake. Q is equal to what? Minus q root 2 plus 1 by 2, and this is 2. Q is equal to minus q by 2 root 2 plus 1 by 2. So this is the answer. For this question, write this is the square and the side of the square is A. Fine, this is the small q, capital Q it is, this is capital Q, this is small q. So we have to find the value of capital Q so that the force on, listen, we have to make the force, this is A root 2, the force assumed to be F1, both are same sign, so the result repulsive force will be equal to K Q upon A root 2 whole square, KQ square upon 2A square. Is it clear? Yes. Because of this Q, the force must be attractive, so therefore it must be what? The negative sign. And this is the F dash. What is the resultant of F dash and F dash? Yes, F dash is equal to F dash root 2. And what is the value of F dash? Is equal to KQQ upon A square. So the resultant of this is F dash root 2. So for equilibrium of Q, the F1 plus F dash root 2 must be 0, or you may write in this way. So F dash root 2 must be equal to minus F1, right? So this is the F1, KQ square upon 2A square, and what is the value of F dash? Say KQQ upon A square root 2. Is it clear or not, you tell? Yes. Simplify this. So this is Q root 2 is equal to minus Q by 2. So the value of Q is Q root 2 minus Q upon 2 root 2. Is it clear or not, you tell? also either the sign, negative sign by come it's on, right? But if yes, if you are equating them, f1 is equal to f dash root 2, after finding the value of q, you have to put the negative sign from yourself, right? So in this question we have the hexagon, fine, and yes, the charge is placed q q q q at all the 5 corner of the hexagon, right? So the magnitude of the force on point charge minus q, we have to find the force on minus q. So if you consider, listen, this is the hexagon, if you consider this the minus q, the force between them, the distance, right, if it is L, so all the side will be L. Is it clear or not, you tell? Yes. Because of this charge, the force will be attractive, the force is F, right? Because of this charge, force is attractive. So they will cancel each other or not? Yes. Although the force magnitude will be equal to this, but they will cancel. In the same way, this is q and minus q. The force is attracted by this charge. The force is attracted by this charge. So these two forces also will cancel. Fine. Only this is the charge q which will apply the force F in this direction. So if you consider this the minus q, the force F is only. So this is the force k q square upon L square. Is it clear or not? Yes. And you may write if it is A, B, C, D, E, F, and this is O. So along OD, because force is a vector quantity and you have to give the magnitude as well as direction, right? Copy this. So in this illustration, suppose these are the two charges, capital Q and capital Q, and this small charge is placed at the mid. The distance is A, the distance is A. Can you tell me what is the net force on this charge initially? Say 0, because the force due to this charge 1, F1, because of this the F2, the magnitude will be F1 and F2 will be equal and opposite. So is it in equilibrium? Are you getting or not? Yes. Is it in equilibrium? Now if you displace the small q charge from the mean position by a small displacement x, so this is the capital Q, the distance become a plus x, and for this capital Q the distance become a minus x. Is it clear or not? Yes. So if I assume this is the charge 1, it is the force F1, this is the less force because the distance become a plus x now, and the force, this is the charge capital Q, the force become F2, it is greater because the distance is say a minus x. Is it clear or not, you tell? Yes. So is it in equilibrium? Say no. Which force is greater, you tell? F2 or F1? F2. So what is the net force, or you can say the restoring force? The restoring force. What is the restoring force? It is F2 minus F1. So what is the value of F2? The F2 value, because of this k q q upon a minus x square, k q q. What is the F1? A plus x whole square. You may simplify this. K q q, if you take common, then what will you get? 1 upon a minus x whole square, a plus x whole square. Fine. I am writing this side. The restoring force is equal to upon, take the LCM and multiply, cross multiply, a minus x whole square. So now you may simplify. This is a square minus b square, a plus b, a minus b, right? Yes. And this is a minus b, a plus b ka whole square, it may be written as a plus x, a minus x whole square. Please tell, the calculation is clear or not, you tell? Minus x will cancel out, plus a will cancel out. So this is equal to 2a and this is equal to 2x. Become a square minus x square whole square. Getting or not?
Yes.
This x displacement is very small as compared to the a. So it can be ignored. KQQ. This has become 4ax upon a square whole square a की power 4. Is it clear or not, you tell?
Yes.
So therefore, the force may be written as 4kq, right, x upon a की power 3, a upon a की power. So this is the net force. Listen one thing, this is the mean position, you give the displacement in the positive x direction. But if you consider the mass of this particle is m, the net force is in this direction, therefore acceleration will be towards left. So if the force is positive, the displacement is in plus x direction, the acceleration is minus a direction, minus x direction. So net force will be equal to minus m into a, right? So 4kqq upon a cube into x. Listen one thing, although this is the a is the distance, I am taking this distance here d cube so that you are not confused with the acceleration a. Is it clear or not?
Yes.
This is the acceleration a, this is the distance d. So acceleration is 4kq upon d cube, m come this side and this is the minus x. So from this equation, the acceleration is proportional to, say, minus x. Therefore motion is SHM. And compare with standard equation of SHM. This is the equation number 2, this is the equation number 1. So what is the omega square? The omega square is 4k qq upon m into d cube, right? First copy this. So now you can simplify further. The omega square value, I am writing this side. Omega square is equal to 4 into 1 upon 4 pi epsilon naught q upon d cube, right? 4 will cancel out. This is m is also left. Omega is equal to square root of qq upon pi m epsilon naught pi epsilon naught m d cube is equal to 2 pi by t. So what is the t? Is equal to 2 pi root pi epsilon naught m d cube upon capital Q into Q. So this is the time period of oscillation, right? Copy. So in this question, this is the capital Q, this is also capital Q. Initially the charge is in equilibrium over here, right?
Yes.
So now if it is displaced perpendicularly, in the previous question it is displaced along the line. So if it is displaced perpendicularly by a small displacement, this x is the very small, right? Suppose this distance is d, right? I am assuming this distance is d, right? This charge is negative. To be perform SHM, this charge must be negative. Why it is so? Listen, if this charge is positive and if you displace this little bit, so plus charge, the repulsive force F and the repulsive force F. So the resultant of this force will be Fr. So if you displace a little bit, it will be in unstable equilibrium and it will continue to move to infinity. Are you getting or not? But if this charge is minus q, the direction of forces are reversed. So if you displaced little bit from the mean position, this is F and F. So the resultant restoring force will be equal to what? You tell. The Fr. This is the displacement x. So if you assume this is theta, x is small, fine. So if this is the minus charge, this is theta, so the F cos theta and this was also f cos theta, right? So they will cancel each other. So what will be the restoring force? Restoring force will be equal to what? Fr is equal to 2f sin theta. Is it clear or not, you tell?
Yes.
2f sin theta. So this is the resultant force. So what is f? If this is d, this is x, this distance is d square plus x square. So what is the value of f? K q q. I am not taking the minus sign. I am writing the magnitude root over d square plus x square. D square plus x square. Are you getting? And what is sin theta? You tell. Perpendicular upon?
X upon
Yes, x upon d square plus x square. So here I will write the 2 into f k q q upon d square plus x square, right, into sin theta is x upon root over d square plus x square. It may be written as k q q upon d square plus x square raised to the power 3 by 2 into x. How it is? X into root x, right? Or you may assume k into root k. What is k into root k? K into k raised to the 1 by 2. It is 1. 1 plus 1 by 2. It is power 3 by 2. That is why it is written as raised to the power 3 by 2. Fine. If the mass is m, this is the net force. The displacement is in this direction. The resultant force in this direction. So acceleration is opposite to the displacement. So therefore this net force, which is called the restoring force, may be written as minus m into a. So the acceleration may be written as 2kq upon d square plus x square raised to the 3 by 2 into minus x. Fine.
Yes.
This is the acceleration. This is the minus displacement. Seen accelerations is proportional to minus x. Therefore, motion is SHM. Please copy this. So, if this is the SHM, this is the equation 1. Compare with the standard equation of SHM. Right. The omega square may be written as 2kqq upon d square plus x square raised to the power 3 by 2. Fine. I will put the value of k. This is capital Q upon d square plus x square raised to the power 3 by 2. Are you getting or not?
Yes.
Listen, one more thing. One more thing. This x can be ignored, right? This is less than d, so it can be ignored. So when it is ignored, so the d square raised to the power 3 by 2, it becomes equal to what? D cube. So can I write this is only the d cube?
Yes.
So this is d cube and this is also d cube. So simplify this qq upon 2 pi epsilon naught. Also there will be m. There will be m, right? 2 pi epsilon naught m d cube, right? This is the square root. It is equal to 2 pi by t. So the time period 2 pi into 2 pi epsilon naught m d cube upon cube into cube, right? So this is the time period of oscillation, and it will perform oscillation perpendicular bisector on perpendicular bisector, right? So in this question, the two charges, right, q1 and q2, and the separation between them is r k q1 q2 upon r square, and the force is given as the 100 Newton. Now the distance is increased, right? What is the distance? R dash is equal to r plus 50% of r. So I think it is 1.5 r. So now the force will definitely reduced, right? Calculate the force. The F dash become k q1 q2 upon r dash square. Is it clear or not? This is the equation number 1. Equation number 2. Divided 2 divided by 1. So 2 is F dash upon F. Fine. F dash is K Q1 Q2 upon R dash square. K Q1 Q2 upon R square. So R square upon R dash square. Is it clear? So
Yes.
F dash upon 100. The R is R. The R dash is 1.5 R square. Fine. Is it equal to 2.25 R square? 2.25. So the F dash become 100 upon 2.25 Newton. You may simplify and you can get the answer. Fine. Copy this. So in this question, the two neutral small spheres were there. No charge were there. And because of friction, right, the 4-meter distance between them, right, if after rubbing, the some charge or the some electron will transfer from one sphere to another sphere. So if the electron are transferred from one sphere to another sphere, so the equal and opposite, the plus q and the minus q charge will appear, whether q is equal to n into E. Is it clear or not? And therefore they will attract. So what is the electrostatic attractive force? K QQ upon R square. Fine. This value is given as the 3.6 Newton. So the K is 9 into 10 to the power 9. This is Q square and this is 4 square. So this may be written as 16. 9 into 10 to the power 9. It will come in denominator. If you simplify, you will get the answer. This is Nochok 36, 6.4 into 10 to the power minus 9 Q square. This is 64 into 10 to the power minus 10 is equal to Q square. So the Q value is 8 into 10 to the power minus 5 Coulomb. So this is the charge on each sphere. Now we will find in the second part the number of electron is given by Q upon E. It is 8 into 10 to the power minus 5. The electronic charge is this. Is it clear or not, Utal?
Yes, sir.
So if you simplify, this is 16 into 10 to the power 14, right? You will calculate this. 16 5 into 10 to the power 14. Number of electrons are transferred from one sphere to another sphere. Is it clear or not? Copy this. So in this question, right, there are 2 point charges. This is capital Q and this is capital Q. And on opposite corner of the square small q, so we have to find the value of Q so that resultant force on the capital Q is 0. If I assume the side of the square is D, so the force exerted by this is F, right, this is D root 2. This F1 will be equal to KQQ upon, right, D root 2 whole square. This is KQ square upon 2D square, right?
Yes.
Now it must be the negative charge because this is the F2 and the same force is exerted by F2. So F2 and F2, if both are perpendicular, right, so their resultant will be equal to what? F2 into root 2. So F2 into root 2. And what is the value of F2? F2 is the force between small q and capital Q. The value of F2 is KQQ upon D square. Is it clear or not?
Yes.
For condition for net force on charge is 0, is that F1 vector plus F2 root 2 vector must be null vector. If you take this the vector, so therefore the F1 must be equal to minus F2 root 2. The F1 force because of this charge is KQ square upon 2D square must be equal to minus the F2 is, this is the F2 value, K capital QQ upon D square into root 2. Is it fine?
Yes.
So the value of, you may simplify, D square will cancel out, Q upon 2 is equal to minus Q root 2, right? So the value of Q must be equal to minus Q upon 2 root 2, and the value of Q in the question is given as, it is plus root 2 microcoulomb. So if you put minus 2 into 10 to the power minus 6 upon 2 root 2, this is the root 2, it will cancel out. So minus 1 by 2 into 10 to the power minus 6 coulomb. Q is equal to minus 0.5 microcoulomb must be the charge, right? Copy this. So in this illustration, in this question, we have the equilateral triangle, and this is the charge minus 100 microcoulomb. This is what? Q plus 100 microcoulomb, and this charge is minus 100 microcoulomb. This is the charge A, this is B, this is C. This is 10 centimeter, 10 centimeter and 10 centimeter. You have to find the force on this charge. So if it is minus minus, because of this charge, the force vector is repulsive, plus and minus, the force is attractive. Is it clear or not? Although the force F1 and F2 vector magnitude will be the same, KQQ upon R square. K value is 9 into 10 to the power 9. The Q value is 100 microcoulomb, right? Q square multiply by 2. Is it clear or not? Divided by distance is 0.1 meter. So 0.1 square. You will simplify this. 9 into, right, 10 to the power 9. This is 10 to the power minus 8. Fine. And this is 10 to the power minus 2. Fine. So it is equal to 9 into 10 to the power 3 Newton is the force. Right. I am assuming this is the F. So this angle, this is the point of charge B. This angle is 120. And the resultant of these two forces will be FR. Is it clear or not?
Yes.
So if this is the one force, the magnitude is also F, 120 degree. The resultant force will be written as A square plus B square plus 2AB into cos 120. You will remember always the value of cos 120 is always equal to minus 1 by 2. You have to remember this value. It is used many times. So it is equal to F square plus F square plus 2 into F square, and it is minus 1 by 2. So the 1 minus minus will cancel out. So square root will be equal to F, and the value of F is 9 into 10 to the power 3 Newton only. So this is the resultant force on charge B, right? And this is the direction. Fine. Copy it. So in this question, the two positive charge, this is the plus Q and the plus Q, are placed at some separation D. So the electric force will be equal to what? K QQ upon D square, and according to the question, repulsive force is equal to the weight. That is, it's equal to the weight. So they are asking the value of D. So D square is KQ square upon mg. All right. The value of K is 9 into 10 to the power 9. The charge is 1.6 into 10 to the power minus 19 whole square divided by 1.7 into 10 to the power minus 27 into 10. I am taking the value of G is equal to 10. Is it clear or not?
Yes.
Now if you simplify this, so you will get, if you take the square root, this is the D. If you take the square root, you can take like this. So this come out from the square root, 10 to the power minus 19, 9 into 10 to the power 9 divided by 1.7 into 10 to the power minus 26. It may be written as 1.6 into 10 to the power minus 19, 26 plus 9, this is how much? 35. So it is equal to, I am writing this side only, 10 raised to the 35 upon 1.7. Listen one thing, for simplification, I am assuming this 1.6, right? So little difference will be there, but it is not very much. Into 10 to the power 35. So this is 9 into 6, 9 upon 16, 10 to the power 36. So 3 upon 4 into 10 to the power 18. Are you getting or not? So it is the way to do the calculation in a very fast way. So otherwise it is not possible. The value of this value is 3 by 4 into 10 to the power 18, right? So this is 0.4 and 1.2 into 10 to the power minus 1, 0.12 meter. approximately 12 centimeter is the correct answer, right? Copy. So in this question, there are 3-point charges. This is minus q at B, this is 16q at C, this is 9q over there. Distance is 3a, right? It is 5a. This is not given, but Pythagoras theorem, when you will apply, you will get it is 4a. Is it clear or not?
Yes.
So I'm asked, we have to find the charge force on this minus q. Because of this, force is F1. Because of this charge, force is F2, F1. The resultant force will be Fr, which is equal to what? Tell me. Root over F1 square plus F2 square. Is it clear or not?
Yes.
Right. So what is the F1? F1 is minus the q sign will not be taken. Kq q upon 3a whole square. Kq square upon a square. Is it clear? And what about F2? The force is K Q 16Q upon 4a whole square. Fine. So this is KQ square upon a square again. So this is equal to F. Suppose this is equal to F. So what is the resultant force? Root over F1 plus square F2 square. That is F square plus F square is equal to what? Say F root 2. The value of F is nothing but KQ square upon a square into root 2. So this is the resultant force on minus q charge. Fine. Copy this. So in this question, if a charge, there are two charges, one is fixed charge, the another charge is capital Q of the mass m. It is moving around the charge particle like this. So when a particle moves in a circular path, the required centripetal force is towards the net center force, right? So net force towards center, net force towards center will provide required centripetal force, right?
Yes.
Centripetal force. The net force toward the center is what? If this is q, this is q, so they must be of opposite sign. Suppose this is the minus q, this is the plus q. Otherwise there will be repulsive force and circular motion is not possible. So the electrostatic force will provide required centripetal force. If we assume the radius of circular path is what? Say r. Fine. The electrostatic force is K q upon r square is equal to mv square upon r. Are you getting?
Yes.
So from here we can find the v square is nothing but kq upon m into r. Is it clear or not? So the speed I can write in this way. All right. Now how to find the time period of oscillation or time period of revolution? 2 pi r upon v. Right. So radius is capital R given. So you just change the value capital R upon v. V is the square root of kq upon m into r. Fine. So this is equal to 2 pi r root over mr upon k capital Q. Is it clear or not?
Yes.
So we have to find the value of t square. Therefore make the square both side 4 pi square r square. It become mr upon kq. Right. So the t square is 4 pi square m into r cube upon k. Value is this q into q. Multiply 16 pi cube epsilon naught m r cube upon q into q. So this is the value of the t square, which is exactly matching in the given. Right?
Yes.
Copy this.